This lesson is an introduction to conic sections. So conic sections are all developed by intersecting a plane, which just is a flat region that goes on forever in all directions, with a double napped cone. So as you can see, this is a double napped cone. Here we can see that it intersects in a circle. It could also be an ellipse, which is essentially sort of an oblong circle. A hyperbola, we're looking at sort of two parabolas going in different directions. And then of course, just one parabola. So those are the conic sections that we'll focus on. We've already learned about the circle, but I'm going to review all four of them with you. So the circle that we've already talked about is the set of all points x, comma, y in a plane such that they're equidistant from the center point, which is right here. So the center point, they're all essentially are units away from the center point. We've already talked about the equation of a circle. X minus h quantity squared plus y minus k quantity squared equals r squared, where r is the radius. And of course, h comma k is the center of the circle. One of the first ones that we're going to talk about in the three new conic sections that we'll study is the ellipse. So the ellipse is the set of all points such that the sum of the distances between x, y, and 2 points, called the foci, is constant. So here's an example. There are 2 foci, and the sum of those distances would be the same as the sum of these distances, etc. So any of the points would be, the sum of those distances would be the same. As you can see, we have, if the a value is below the x, then we have an ellipse that is sort of stretched horizontally. And if the a value, which is always larger than the b value, a is always greater than b. If the a value is below the y, notice it's oblong in this direction rather than this direction. The hyperbola is the same idea as the ellipse, except notice now we have the minus in between. And so instead of taking those two sides and coming together, now the two sides are coming apart. So that's the difference between the two. Same idea, the hyperbola is the set of all points such that the differences in the distance, so now differences rather than sum, between x, y, and the foci is a positive constant. We'll talk about how to graph these later. But again, just as before, if the a value is below the x, notice that it's this direction. And then if the a value is below the y, it is now this direction. We have talked about a parabola in the past. However, we used a different form. So we used ax squared plus bx plus c. In this lesson, or in this week, we're going to talk about this standard form that's going to help us to be able to graph it a little bit easier than perhaps the way we graphed it before. So again, this is the set of all points x, y that are equidistant from a fixed line called the directrix, which would be this one right here, or this one right here, and a fixed point called the focus. So it's equidistant from those two things. One thing I would like us to get out of this intro lesson is to be able to look at a function, at a conic section function, and determine which conic section it belongs to. So things that I'm looking for, the one that's easiest in general is the parabola. So if you'll notice, this has an x squared and a y squared, this has an x squared and a y squared, x squared and a y squared. This one only x or y will be squared, and so that would be the parabola. That's generally the easiest one to deal with. The second easiest is the one that has the subtraction sign in between, but remember to pay attention to the fact that this is positive and this is positive with the subtraction in between. So looking at that, I know that that is the hyperbola because of the subtraction sign. The circle and ellipse are often quite similar, and things that you have to look for here, because notice they're both plus and they're both squared. Things that you should look for is the denominator. If this denominator were the same as this denominator, it would actually be a circle that is, sort of masquerading as an ellipse. So when those denominators are the same, it actually is a circle. These denominators are different, so this is an ellipse. This is a circle. Remember, looking at the center would be 0, 2 with a radius of 3, but that would be a circle. Here's one for you to try on your own. So match each function with the appropriate conic section and then press play to check your work. So again, looking for the easy one first, I'm looking at the parabola because the parabola only has one squared value. So in this case, the x is squared, the y is not. Then I would look at probably this one next that has the subtraction sign in between. Again, notice it has different denominators, not as important for a hyperbola, but that would be a hyperbola because of the subtraction. Looking at these two, again, this one is a circle. And what I was talking about on the last screen was sometimes you might see it written like this, which would be the exact same function. It's still a circle because the denominators would be the same. This one has different denominators, and so that is my ellipse.